Okay, so we have talked about fragmentation just now, possibility of fragmentation. And remember, the most important point about fragmentation is that in case of fragmentation, during collapse, what will happen? One thing is inevitable. Temperature may increase, may decrease depending on the cooling mechanism, how efficient or inefficient it is. But one thing is important, density will increase, right? Density will always increase. And for fragmentation, we must have that Gibbs mass must decrease if density increases. So, if Gibbs mass decreases, then only fragmentation will happen, small parts. Okay, now you see, during the cloud collapse, the initial phases is rather isothermal. Why? If you ask me, the reason is quite simple. In the initial phase, the particles are very far from each other, low density. So this means they are efficient cooling mechanism. There is not much chance to absorb the energy. You can also say optically thin. I will explain these terms later on. So because of this efficient cooling mechanism, what happens is that the energy released due to this gravitational contraction is radiated away. Now again, when I say this, remember the stuff. It is entirely going lost. Fine. But is this statement correct? There is a catch. Remember, Virial theorem is valid. So this means half of it will increase the kinetic energy and half will be radiated away. So this is what I mean. So it will be radiated away. Now later on, what happens if the density increases, the interparticle distance will decrease. What will happen is that energy released will be used up more to increase the internal energy. Gravitational contraction energy, released energy will increase the internal energy, and this is because of inefficient cooling. The radiation or the energy is being trapped inside the cloud. Now let's see what happens in case of isothermal contraction. So I am saying in initial phases it is isothermal. In case of isothermal process, we know PV is equal to RT, that means T proportional to V, or you can write V as mass by density. So this means P is inversely proportional to density. Now we already know the structure of the Gibbs mass over here, right? And so we can write, you see, from there if you put in the terms, we get Gibbs mass is proportional to 1 by rho square. This means that as during the isothermal contraction, density will increase, right? And what will happen to Gibbs mass? It will decrease. So this means that fragmentation is possible during the initial phases due to isothermal contraction. Now later on, we have adiabatic process, as I was saying. Now what happens in this case? Let us consider a monoatomic gas, so gamma equal to 5 by 3, and we have this relation T into V to the power gamma minus 1 is constant. So from here I am already getting T proportional to rho to the power 2 by 3 after putting the value of gamma equal to 5 by 3. So this means that Mj is proportional to density. So this means if density increases, Mj also increases. So no fragmentation. Understand? So fragmentation that we have already discussed, which is the reason behind the formation of stars after gravitational contraction. This is possible during the initial isothermal contraction phase. I will talk more about it later on in my next classes. What happens? How this internal energy goes on? You see, first we have in the giant molecular clouds, mostly we have hydrogen gases. Hydrogen molecule, that means H2. So what will happen? First H2 will be dissociated. Energy first goes to dissociation of molecule. Later on, if we consider individual hydrogen atoms, then energy will go to ionize the hydrogen atom. So this way slowly the energy will be eaten up. Okay. Now this is very important. So why fragmentation occurs during the isothermal process and not during isothermal contraction and not during adiabatic contraction. You can get a clear picture if you consider the mathematics. You see the very basic. So any questions till now? Today's class is over. So this much for today. You must remember, for fragmentation, Gibbs mass must decrease as the density increases. Okay. So we have discussed these two criteria. One is the isothermal process and another is the adiabatic process, and I have already worked down the mathematics for these two parts, right? This is very important.